A box contains 6 red marbles, 4 green marbles, and 10 black marbles. 8 marbles are randomly selected with replacement. Number 1, what is the probability of getting 4 red, 2 green, and 2 black marbles? Number 2, what is the probability of getting 3 red, 1 green, and 4 black marbles? These are examples of multinomial probabilities. These resemble binomial probabilities, except remember, with binomial probabilities, there are only 2 possible outcomes, success or not success. Here, we have 3 possible outcomes, depending on the color of the marble. Because there are a total of 20 marbles, 6 of which are red, 4 of which are green, and 10 of which are black, the probability of selecting 1 red marble is 3/10. The probability of selecting 1 green marble is equal to 1/5, and the probability of selecting 1 black marble is equal to 1/2. And again, we are selecting with replacement. So for a multinomial probability, there are n independent trials. In our case, because we are selecting 8 marbles, there are 8 independent trials. Each trial results in one of the k mutually exclusive outcomes, which in our case should be the color. On any single trial, these k outcomes occur with the probabilities p sub 1 through p sub k, which we just gave in the table. The sum of the probabilities is equal to 1, and the random variable x sub I represents the number of occurrences of I. And we have the formula for a multinomial probability at the bottom. Let's go back to our examples. Again, number 1 is what is the probability of getting 4 red, 2 green, and 2 black marbles? We can represent this as the probability that x sub 1 is equal to 4. This represents getting 4 red marbles, comma, x sub 2 equals 2. This represents getting 2 green marbles, comma, x sub 3 equals 2. This represents getting 2 black marbles. And this is equal to, we have n factorial divided by x sub 1 factorial through x sub k factorial. So because we are selecting 8 marbles with replacement, we have 8 factorial in the numerator. And then because we want 4 red, 2 green, and 2 black marbles, we divide by the product of 4 factorial, 2 factorial, and 2 factorial. This gives us a number of ways of getting 4 red, 2 green, and 2 black marbles. And then we multiply this by the probability of getting a red raised to the 4th power, which would be 3/10 to the 4th, times the probability of getting a green marble squared, which would be 1/5 squared, and then times the probability of getting a black marble also squared, which is 1/2 squared. So if we pause here for just a moment, we have 8 factorial here because we're selecting 8 marbles with replacement. And then because we want 4 red marbles, we have a 4 factorial here and an exponent of 4 here. Because we want 2 green marbles, we have a factorial of 2 in the denominator here and an exponent of 2 here. And because we want 2 black marbles, we have a 2 factorial in the denominator here and an exponent of 2 here. And notice how these probabilities here are the probability of getting a red, the probability of getting a green, and the probability of getting a black. Let's go ahead and evaluate this on the calculator. Notice on the right we have a decimal. If we want the exact value as a fraction, we simply click Convert to Fraction. I'm going to go ahead and record the fraction as well as the decimal. Which is a percentage, would be 3.402%. To convert a decimal to a percent, we multiply by 100, add a percent sign. Let's take a look at the second example. We want the probability of getting 3 red, 1 green, and 4 black, which we can represent as the probability that x sub 1 is equal to 3, x sub 2 is equal to 1, and x sub 3 is equal to 4. Which is equal to, we begin with 8 factorial because we are drawing or selecting 8 marbles. And then because we want 3 red, 1 green, and 4 black marbles, we divide by the product of 3 factorial, 1 factorial, and 4 factorial. And then we multiply by the probability of a red marble raised to the 3rd power, which is 3/10 to the 3rd, and then times the probability of a green marble raised to the first, which is 1/5 to the first, and then times the probability of selecting a black marble raised to the fourth, which is 1/2 raised to the fourth. And now we go back to the calculator. As a decimal, we have 0.0945, or as a fraction, we have 189 2,000ths, which as a percentage is 9.45%. I hope you found this helpful.